Okay, we got our review for Q19. Working on the last problem here, which is the block held at two different angles. And what we're interested in doing is finding the two tensions of the cables that are holding up the block. The first thing I would do in this problem is find the weight, because that's the easiest of the three forces to find. So it's just 30 times 9.8. That gives us 294 for the weight. So I'll just write that in. 294. Finding the other forces are quite a bit, more difficult to do. In doing this, what we really want to do is we want to focus on the x summation first, then go through and deal with the y. So when talking about the x, we have a certain amount of tension that is directed. I forgot my red was dead. We've got a certain amount of tension that is directed this way. So we call that FTX, FT1x. And we have a certain amount of tension that is directed this way, which we would call FT2x. And then likewise we have these y components. So we have a certain amount of y component, FT1y, and a certain amount of y component here, FT2y. Now if you look carefully, you'll notice that the x's are identical, but the y's are not, and that's why FT1 is so much greater than FT2, because they have the same x but a much larger y component for the 55-degree angle one. We know that 55 will give us more tension. FT1 will have to be bigger than FT2. You can see that by just looking at the magnitude of the arrows. But when we get down to the specifics, it gets a little bit more complicated. So let's do an x summation here. We got sum of forces in the x, and then we have FT1x minus FT2x equals 0. And then we can kind of figure out exactly what FT1 is. So we take FT1 hypotenuse times the cosine of 55, and that minus FT2 cosine 33 equals 0. Then all we have to do is bring 1 to the other side. So we want to kind of bring FT2 over. So FT1. Now let's go ahead and figure out what cosine 55 is. Cosine 55 is 0.57. So I'm going to round that and write that in right there. 0.57 equals FT2. We're going to take the cosine of 33. So we say cosine 33, and we get 0.84 if we round. So now we can get one compared to another by dividing. So if I want to get FT1 by itself, and I do, I divide both sides by 0.57. So I get 0.84 divided by 0.57. That gives me 1.47 FT2. So if I have an FT1, it takes 1.47 FT2s to equal it. Let's go back to our picture and see if that makes sense. It would take a lot of FT2 to equal FT1, almost 1.5 FT2s to give us 1 FT1. So that should make sense to you. This is a very important relationship that we just found. I'm going to want to write that down somewhere because we're going to refer back to it. So I'll put it right here on my main page. FT1 equals 1.47 FT2. Now you could have done it the other way around and solved in terms of FT2, and that would work as well, but it would give you a number that's less than 1, which is fine. It works fine. Okay, so we got that done, and now we're ready to start working on the y summation. So that's the second part of this, is the y summation. Sum of forces in the y. We've got FT1y plus FT2y. Those two things added together, minus FMG equals 0. So rather than saying FT1y, we'll sub that in with the trig function. FT1 sine of 55 plus FT2 sine of 33 minus 294 equals 0. So once again, I want to kind of simplify what I can, but this time I also want to get rid of FT2 by putting in 1.47. Oh, I did that wrong. I want to get rid of FT1. Sorry about that. I want to get rid of FT1 by putting in 1.47 FT2. And now I have like terms of FT2. I have FT2 and I have FT2, and that's going to allow me to be able to solve this. So I subbed in FT1 because FT1 equals this amount of FT2, and it changed and became that. So then I can also then multiply that times the sine of 55. So we'll do that. Sine 55, and we'll multiply that times 1.47 FT2, and that gives me 1.2 FT2. 1.2 sine of 55 times 1.47. So now I have like terms of FT2. I might find the sine of 33 to simplify over here. So I have 0.5, let's say 55 FT2, and that minus 294 equals 0. So now what I want to do is add these two things together. 1.2 plus 0.55. A lot of rounding error here. We get 1.75. 1.75 FT2 equals 294. Then all I need to do is take 294 and divide by 1.75. That gives me 168 for FT2. So I found FT2 to be 168. So I know what that is. And as soon as I know what FT2 is, I can then plug that in up here, figure out FT1 is. I multiply that by 1.47. I get 246.96. I'll just say 247. 247 is what I get. So, you know, that makes sense because FT1 should be bigger than FT2, but how do you know for sure? How can you tell for sure? You wouldn't know for sure unless you went back through here and checked to see if this works out. If we can then take the cosine, or 0.57 FT1, you can kind of check it here using these kinds of things, and you should get the same answer. So it should work out, but we'll just do a quick check here. We'll take 2.47, which is 247 times the cosine of 55 gives me an x component of 142-ish. And it won't be exact because of rounding, but it does a pretty good job. Then we can do 168 times the cosine 33. As long as they come up pretty close, which they do, then we know we did it right. You can also check it with the y summation if you want to. There's another way to check. So I can then put in my number 247 sine 55 plus 168 sine 33. Put those together and I get 136, and the weight was 294. So that's probably just a little clerical error. Let's try it one more time. We'll take 247 times the sine of 55. Let me get my number this way this time. And then I'll take 168 times the sine of 33, and then I'll take 202.3 plus 91.5, and then it matches better. 293, and then it works. I got nervous there because I was messing around jacking it up by putting in all the parentheses. Somewhere along the way there, my parentheses, doing this first, messed me up. So just do them separately and add them together, and you can check it that way. But it works, and we checked it, so these are our answers for the tensions. And the shorter cable did have more tension. Greater angle with the x-axis, more tension you get. Alright, see ya.